Swayam Prabha. Digital India. Educated India.
Hello everyone, my name is Abhishek Jaiswal. I kind of designed a ventilated helmet for Indian, specifically humid market, and I did it under Professor B.K. Chakravarthy from batch 2020. So I'll give you some brief glimpse about what this project was and why I started it and what we achieved at the end of it, right? So this report and this presentation involves both the designing process of it and also what happened when we tested it in real environment against other helmets which are already done by some manufacturers. Okay, cool. So how many of you, I'm very sure a lot of you are into bikes and some kind of motorsports, right? And many times you people have felt that scenario where you are into a very hot climate and these safety gears are very thick designed, so you sweat a lot under those conditions, right? So you cannot focus onto your sport or you cannot focus onto your driving skills and all, right? So I kind of come from the same domain, so I felt a gap in this whole scenario. So I thought I'll just design something which makes more sense over here. So so this design is not specifically for Indian market. It can be allocated to any geographical condition which shares very dry or very humid hot climatic conditions. Okay, so okay, before I start describing how I did this project and how we tested that, let's talk about why this project came into existence. So first of all was how I found this problem, and that was because I come from a motorsport kind of a enthusiastic field field. So I felt that problem, and second was a lot of these products which come to our country are directly taken from some manufacturer who is situated in some other country, right? And over there in that country specifically, they might be having some very cold or very different kind of a climatic condition, right? When they start manufacturing that product and selling it here in India, they don't make any crucial change so that it improves the usability factor of it over here. They just import it and sell it to the user without even caring about how it will perform under this condition. That's why lots of outside manufacturers, bike manufacturers also fails in India because they don't have their thing designed according to our country, right? Cool. So before jumping to designing the helmets or designing any kind of a product, we need to understand what that product really is about, right? So this is just a very generalized overall depiction of the anatomy of or construction of the helmet, but there is more into the picture which we will unravel as we will go further into the presentation. Okay, so obviously there are three major crucial parts of the helmet that we need to look after, that we need to change or modify in order to achieve more breathability or more sweat protection into that thing, right? So the first one was shell, the outer shell, the hardest part of the helmet, which basically absorbs most of the shock while in any kind of a accident or something. Second was EPS layer or styrofoam layer inside that, or some kind of a foam layer or padding. Then there is a foam padding below that which makes contact between that EPS layer and your head. There are some kind of liners also in most of the cases, but nowadays manufacturers are kind of cutting cost on that. Cool. So there are some other components also, but these three components were major or were in focus when I was designing or redesigning this concept. Okay, so there are some more key details about what these things are, and now here comes the first bump in my project, that I never imagined, and that was there are some standards when it comes to protection gear. Specifically things like helmets and something which has to be used on under high pressure or high performance, right? There are some regulations and there are some rules generated by our government which every manufacturer or every designer has to follow, right? A lot of those rules are about modification of those tools. Like you all know how it's a kind of a crime to even change the paint of your motorbike or your car, right? You cannot even change the engine capacity or handlebar mirrors or anything, but people do it, right? So before designing this, to make my modifications on my new design of helmet more parallel to the marketable product, I just learned and I just went through these rationales or rules which is governed by ISI in India, and I just try to make the modifications under their radar, right? Cool. Now so there are some user studies before we commence the designing or ideation process, right? We go to the cool sketches and all. We always go for some kind of a data clarification, like what this problem is about, right? So the first one that we researched for research purposes. We went and interviewed lots of people, lots of professional people, professional bikers, lots of daily commuters, lots of long daily commuters who have to move like 150 kilometers per day to go to some regional site, work over there and come back and all that stuff, right? So, and Mumbai being very good place for these kind of people, you can find each and every category of people over here, specifically those people who have to commute out of Mumbai and work over there and come back in some kind of a factory on outer skirts and all, right? So there are some factors that we found which we need to look after. So first one was discomfort, for which we are redesigning this product. Discomfort being you are riding on a very sunny day and you start sitting and there is no ventilation, there is no wind coming in. Even if you open the visor, there is sweat formation over there, right? It is not going anywhere, and ultimately you try to take it away. While in some of the cases, people try to take that helmet away while driving as well, right? And that, in most of the cases, that leads to accident and some fatalities as well, right? Second is storage and management. So there are some other problems also that I took into account, which I felt like I may look over to solve, or I may just incorporate them in my design so they get resolved as well. So storage and management is an issue. Lots of people are just carrying their helmets over here while walking into the mall or something, right? Then reduced senses. There are lots of helmet specifically in the lower end market which can reduce the noise or honking noises from the back. You are not able to hear what people are saying from the outside even when the lid is open and all that things, right? So we need to look over that also. Hygiene is a huge issue. You don't want to wear somebody else's helmet, right? If that guy is sweating a lot, you will not even want to look inside that helmet. That's kind of a situation. Then you have fogging of visor, specifically in humid and cold weathers, right? Fogging happens. And then aesthetics. Okay, aesthetics, I just took it over here because specifically if you look at lower end market of helmets in India, right? They are very functional, I'll say they look very cheap, or they look very normalized, right? Nowadays companies are doing very good stuff, like there are some LS2 helmets or studs helmets which are coming into the picture, bringing lower end helmets into the aesthetic market, right? So yeah, that's the thing. So these are some of the insights. Now the second thing that I have to do was to understand how helmet works structurally, right? What are the surfaces that I should not touch in order to keep it structurally sound, right? If you are going to make changes to any of the crucial component of any product, then that component should not be modified at the point which makes it weaker, right? We should find out some point where it doesn't affect the structural integrity of that whole product that much, right? So we went and we just affiliated one of the tests that is done by ISI and some global standard people also, to test out how and what segment of a helmet shell performs under what kind of stress loading, right? So the darker red area that you are seeing are more prone to break under heavy loading, and the whiter the area gets, it is lesser prone to break under heavy loading. So you can see there are lots of areas which do not break no matter how impactful your accident was or what. Then there are some areas which breaks in a second, right? Like the chin guard. Correct? Cool. So after digesting all this data, from the ISI and this load test and all that stuff, and the BIS standards also, I redefined what my objective was. It started as an idea, like I need to redesign a helmet which is more comfortable for Indian market, right? But now I had a clarity about how I'm gonna achieve it. I had standards in my hand, I had lots of user studies in my hand, I had solid data, and I knew what direction I will take. Correct? So I had created a kind of a design brief. So design brief was more about, so I call it, I ended up calling that helmet design Venta, because it was more about vents and it was more about strength. So yeah, so the primary brief was to have a good air circulation at even minimum speed of 20 km an hour. How we reached that specific number, 20 km per hour, that was the bare minimum speed that you have to have while in a very busy road as well, right? So until unless you stop, obviously it won't work. If you you can have a kind of a air circulation in stop position as well, but you have to have that electronically controlled or temperature controlled helmet, which are like very costly and not even available in Indian market nowadays, right? So yeah, so when you are riding the bike and you are at least 20 km per hour speed, that thing has to work, and that has to provide a good air circulation inside, right? Second thing was contemporary aesthetics. As a designer, I always had a thing for aesthetics about the product, and I had a lot of complaint about what companies do to make something, to produce something cheaper. The first thing they get rid of is the good looks of it, right? Just to make things cheaper, right? So I don't like that step, and I wanted to add that into the cheaper market as well, right? Second thing was to make it more hygienic, right? And the fourth thing was to have this whole redesigning of the helmet get in compliant with the BIS standards, right? Cool. All right. So after that, I looked after several processes how we can achieve one working principle for our helmet, right? So there are lots of products which you can look after in order to make it work, in order to make this helmet work, right? So first one will be very common, you all have seen it, and that is basically activity athleisure wear, right? You have this sports t-shirt and all, you're working out and you're wearing this specific fabric, some kind of a nylon fabric, right? And what it does, it just wicks out the moisture from your skin, and just it evaporates it into the environment, and it does it very quickly, right? So you have this coolness effect on your skin all the time, right? And you're not even when you are just stationary and performing some exercise, you will feel that thing working on. Correct? So I just wanted to have these kind of ideas and these kind of rational principles working in my concept as well, right? So sometimes even when you're designing some specific type of a product, you need to look at different categories of product which have same kind of a work principle, right? Like moisture wicking was my main concern, so I looked onto the products which do moisture wicking but are not basically helmets, right? So moisture wicking was a thing in sports fabric. Then there is capillary action. So capillary action and moisture wicking are kind of same thing, right? Then you have Venturi action. When you pass air through a very tight space, it get cooled down and you have that coolness effect, right? Then you have water cooled inner lining as well. That is more like what we have in water cooled PCs and CPUs and all that stuff, right? So you run cool water through it and you will have that coolness effect inside. So just imagine a helmet where you have a liner or kind of a which has a cavity inside, and there is a pump or some kind of or even a cap somewhere into the helmet. You just stop somewhere, you just buy a cold water bottle and just pour some water in it and you just wear it. It's cool over there. In fact, these kind of this thing is actually utilized by lots of sports equipment out there. There are lots of all season or 4-season biking jackets which have these kind of things in it, right? Cool. So the first thing that first of my ideation sketches was more about having huge chunk of air vents into the front to capture more in wind while driving at low speeds, and to have some kind of a cross ventilation going on, so that you have that pressure development going on at all time, right? If you are just capturing the wind and not allowing it to go outside or not allowing it to leave that volume, then after few minutes or few seconds it will stop working, right? So you need to get the cool air in and get it mixed with your sweat and all that thing, carry it away, and you need to make it exit also from the back, right? So you can have this whole circle going on and on and on, correct? So there are lots of details in this sketch which do not make sense right now. It didn't to me as well. I mean, you don't need to have all things fixed into your first sketch, but yeah, the things start developing from at this stage, right? So that was the first thing. That was more of a Venturi effect. You are passing air with some very small cross section, and you're getting this coolness effect, right? Then there is moisture wicking. So imagine you have this some kind of sports fabric onto the outer shell or inner liner of your helmet, protruding outward, and what it is doing, it is just taking all the sweat from inside, transporting it outside and wicking it out, correct? That can be a thing. It works because over here the fabric will be very dry because of the outer environment, and in there will be lots of sweat, and moisture has this tendency to move to a drier state of environment, right? So it will travel within the fabric. That was the working principle. Cool. So this also has some kind of a aesthetics which suits more towards this working principle, correct? Now obviously we tested it out. We had some mock-ups going on, not wearable helmet specifically, but some kind of a form where we tested like if the Venturi effect or the air slot thing is working better, or this moisture wicking thing is working better. We found the air Venturi effect is working a lot better than the moisture wicking. Moisture wicking works only at some extent. Beyond that, if you have some hyper sweating issue, it will just stop, right? So that's an issue. So we went with air ventilation for some kind of a wind slot into the helmet, right? Now the problem with that principle is that you have to dig or make some holes or make your outer shell weaker in order to make it work. The air has to enter into the chamber and it has to exit from at some point as well, right? So again, the BIS compliance and all that stuff is into the picture. Apart from these two principles, we looked after a lot of other principles. We didn't stop there, like we have two processes so we should stop. No, we looked after a lot of other products, but we found these two to be very interesting. Okay, now once our final working principle was fixed and we knew what we are going to do, and we had that principle in our mind, we started working towards the detail of it. So the first thing that I redesigned was the EPS layer. Okay, EPS layer, this over here looks a lot like a bicycle helmet, but it is not a bicycle helmet. It is just an inner foam layer or thermocol layer of a regular bike helmet. It has this aesthetics of a bike helmet because bicycle helmets are designed to work without a shell. They have all these crevices and all these cuts and grooves just to have higher air ventilation going on. That's why sometimes people like to wear those bicycle helmets also while driving small mobility vehicles, right? You have seen lots of people driving EVs and wearing those bicycle helmets because that's better for ventilation, correct? Okay, so you can see there are lots of grooves over here into the top surface and into the bottom surface also. This sketch represents the inner side of the EPS layer where your head is in contact. So you can see this green arrows are representing how air is getting in towards the inside surface. Over here it has all these canals or some kind of a channeling going on. So even when you have a bigger head and it is a tight contact with the EPS layer, there is some space for air to move around, correct? But those channels cannot be like very huge as well, because the lesser material or the lesser EPS you have, the harder your impact will be. So you have to have some good balance between the two, right? Cool. Okay, so that was the first thing I redesigned. I tested it out as well. Then okay, so for test I'll show you some images like how we did the rigging and how we tested it out with some bicycle guys and some some motorcycle guys as well, right? Okay, so the next thing was the second concern in my brief was the aesthetic part of it, right? If something new is coming into the market, something developed or something better from the previous one, it has to have its own identity visually. Nowadays a lot of EVs are into the market, right? But you can simply identify an EV version of a car from its petrol or a internal combustion version of it. You people can do that, right? Because EVs have their own characteristics and their own design details into the outer shell of it, right? I wanted the same kind of a ideation working over there, right? This helmet has to have some kind of a aesthetics that people can understand and people can visually see it from a far distance as well, right? So for that we had some key factors for this whole project. So our ventilation is the first factor that we have to ideate for. Then there was comfort, then there was high-tech visuals and all those things. So we just took these keywords and I started sketching based on these keywords, like what a 100% or a highly ventilated helmet should look like. In spite of what we have as a working principle, I just started ideating on that, right? So we have some very huge grills. Doesn't matter if this is going to be a very practical design or not, just I try to explore that, right? Because later on we can tweak it up into our own practical designs, correct? So I had some sketches over here. All of them are very heavily based on ventilation aesthetics, how a ventilation helmet will look like, right? Which has very huge chunks of pores in the front, and then there are lots of huge slots onto the back and all that stuff, correct? Then there was some techno, futuristic helmet, what it will look like if we want to have that kind of aesthetics, right? Then we have some kind of a fluid form as a base of a helmet sketching, right? What a fluidic form of a helmet will look like, right? If we want to make it more streamlined, more aerodynamic, then what? So yeah, then so on. After that, after these kind of details, after these kind of aesthetics, we move towards the detailing part of it, because in India or in this country we have all different kind of seasons, and these new designed helmet has to perform in all of them, right? What if in summers a user wants to have that Venturi effect or wind effect, but what about the winters and what about the rainy seasons, right? Then what does we want him to buy another or different kind of a helmet, or we can make our helmet get converted into the normal one, right? So we explored all those possibilities, sketched towards those, like you have these collapsible or closable enclosures and all those things, right? These are quite common details among normal helmets nowadays as well, right? You people must have seen that. Cool. So we keep on ideating some more forms, some more proportions. What you are seeing over here is more kind of a proportion work, like how we can just take one line of a helmet, tweak it a little bit to make it to change its aesthetics, right? Which one looks better, which one looks more functional, which one looks more practical, so on, right? So these are more of the sketches for that. They all look kind of classic, kind of old school helmets, because I have that thing into my brief as well, that I want to make it look like more solid, because we had that thing in our mind, like the old stuff is more stronger than the newer stuff, right? So kind of had that classic helmet theme going on. Then there is one process that I got introduced to into this project by Chaku sir, and that is called affinity cluster. Okay, affinity cluster is a process where you take a lot of your sketches that you have done before and you just cluster them out in multiple groups, right? So we'll see how it works. So you can see all of these, you have seen all of these sketches before as well, right? But now over here they are all clustered into one single word called ease of airflow. They all represent one single word called ease of airflow, right? And there are some highlighted ones which represents this word the most, right? Like these two represents ease of airflow the most among all of these, right? Then you have this one hero concept which is kind of upgraded or combined version of it over here, correct? Which we will discuss about later on. So yeah, that's more kind of a visual or more kind of a digital representation of it. So you take all these sketches and you take your hero presentation of it that we had over here, these two, and then you combine them to have one single design which is 100% there for the word airflow or ease of airflow. So in this frame, this helmet represents the most amount of airflow visually. It works, it doesn't, I don't know, but it visually it looks, it's very aerated, very highly, it's having some kind of a tech which will ease the comfort and the airflow a lot, right? So that's a good point. Second was about closure, the ability to change the airflow property of a helmet, like to be able to use it in all different seasons, right? So we have all those sketches, we have those slots and details. So we have two heroes over here, and then we combined it into one single helmet, correct? So rendered over there as well. So this specific model represents closure of airflow, right? Then we have third, and that is semantics of airflow. Semantics, I mean visually, what a highly aerated helmet will look like, right? So heroes, then we have this one concept, correct? Now we have all these three helmets over here which represent three different segments of this project. One is very functional, one is very closure of function, one is visually functional, right? Now what if we just combine all three of them, then we'll have each and every segment that we wanted in a proper amount, right? So that's what we did. So I'll just show you the end result of it in the last slides, but the aesthetic work ends kind of get halted over here, because after that we need to test our helmet in physical world. So after this slide we will discuss about how I made a prototype and how we tested it out in real world against the real manufactured helmet and how it performed, okay? So then we switch to concept testing. So there's some of the images. These images are from campus only, but I did some of the testing in my hometown as well, and from other regions as well, from some very dry regions as well, where like their summers are like very dry, like Delhi and all, and we tested them out and they performed quite well over there, okay? So let's discuss how I rigged a model and how I made it in compliant with our new designs, okay? So first of all, I was designing this helmet for a lower end market, something which everyone can afford, right? Because in higher end market we already have lots of tech and lots of helmets which have these ventilation features in it, correct? They don't perform that well, but they have it, right? Even if you have those nitrogen cooled helmets nowadays in market, correct? They are really expensive, but they exist, correct? So for our purposes, we wanted something which can be produced very cheaply, which can be on a same price bracket as of a lower end helmets, like $1,000 or $1,500, right? So something like that. So what we did, we just bought standard helmets, very lower end helmets from the market, and we did all the changes or modifications that we planned or discussed earlier, right? Like you people must have seen this helmet, this stud helmet, right? And we just cutted out some slots into the front. We took out the EPS layer. We just made all the changes into the EPS layer, and we just fixed it back, right? Correct. Then this was concept number 2. Again, a different model of a helmet, but which has a kind of a closure for those vents as well, right? So this one doesn't have those closures. This one has a closure, right? How we reached to these two concepts, you people already know, correct? Okay, over here again, then we made some changes to the inner EPS layer, to the liner, to the outer shell, and all those things, right? Right now it doesn't look very safe because it is not. It's just a test rig, and these holes are pretty big for a BIS compliance, but we worked on it later on once we knew if our concept is working pretty well or not, right? So we have some test setups, some factors that we assumed will be constant, and then there will be some other things going on. Before conducting any kind of a test, you need to understand the circumstances and what you're trying to achieve out of it. You need to understand that as well, right? So we just noted down everything. We just controlled all the factors as much as we could, and then we went for the testing. So these are some of the results. So we tested these helmet against some of the helmets which doesn't have any of these features, right? Like I showed you that stud helmet in this slide, this one. So we actually bought two of those. One got modified with these ventilation holes and all, and the second one was kept as it is, factory fresh, right? So while testing, the riders were doing same distance on same vehicle on same climate on same time, but using two different helmets on two different rotations, right? And based on their experience or their some kind of a visual feedback, they were able to number them or rate their experience, correct? So we had this test. So there are multiple parts of it, multiple vent type in that concept which I wanted to evaluate, which one is working or contributing more towards the airflow or comfort, and which one is not doing as much of the work, so that we can just neglect it and we can make our modifications as less as possible, right? So we found both of them doing pretty heavy work in ventilation. Like there is this concept, the concept A, where you have this eyebrow holes and then you have this ear holes as well, side holes, side vents, right? So we ended up keeping both of them because they both were contributing a lot into this whole experience at different speeds as well, correct? Okay, then there are some feedbacks. Then we went to test number 2. Test number 2 was more about what if we change the size of the cutouts gradually, then how much the overall comfort will change, right? So we just told multiple drivers to drive around same path. Every time he completes a rotation, we just tape the vents a little bit by few mm and then read the reading again, right? So by the end of the test, the the vents went from 12 mm to almost 4 mm, right? And based on that changes, the riders were able to rate their comfort level, right? So we found after some point it got stagnant, right? So this way we were able to optimize our cutout dimensions, right? How much we need for how much comfort, correct? So some of the data over here. So why we are doing this test is basically to understand the bare minimum dimensions of those vents. We cannot have very huge cutouts in the shell because that will make the shell or the helmet very weak, right? So we wanted to make it as less as possible, as smaller as possible, but we don't want to compromise with the comfort as well, right? Okay, so there were some of the observations. We had our data. What we did, we just incorporated that data into CAD, and we had our final dimensionized prototype of it, right? These are some of the conceptual details that I have sketched and that we finalized after the testing. So we'll discuss it. So there are some of the vents that we already seen in the prototype, like this ear vents, side vents. Then you have this eyebrow vents over here. Okay, then we have some iteration of how that eyebrow vent will get closed if the user wants to, right? And then there is some exit vents and all going on over here, right? You can see it ended up looking very similar to what products we already have in the market, right? Because that's the thing. If you just launch, or if you just design or produce something which is obnoxiously different from the market, people have this tendency to go against it. They won't use it, right? So it has to be in, it has to have its own characteristics. Like it's a ventilation helmet, so it has to look like a ventilation helmet, but not obnoxiously there, right? Cool. Some more details, some more fitments and manufacturing details, how it will come together, how manufacturing will get ease, because a good design is not just about how it works or how it looks, it is also about how it comes together and how it will be made practical, right? So we had this details and all the sketches and all the details figured out, right? So we have all the different iterations for it, keeping in mind all the data that we had from the tests, right? And some of the other details as well. You can see that. Okay, so we worked on the padding as well, the liner. Apart from EPS and shell, we worked on the liner as well, and then we had our final concept. Okay, see this. So a very generalized simple helmet which has some cutouts on the back to exit the moist air, and some in the eyebrows over here, some vents and some side vents as well. Cool. We 3D printed that, we tested it out, and we fitted all the standard parts from the market after modification, and it works pretty well.